everybody knows how to graph this, but just watch out for the standard mistakes. It should be a dotted line because it's less than, not less than or equal to. And it should be shaded below. The rule is really simple. What's the rule as far as deciding where to shade? If y is less than, it's below. Less than, lower, greater than, above. As long as y is by itself, right? You're not allowed to do anything weird like, you know, say you had 2x minus 3y is less than 4, and you go, oh, y is less than, shade below. No, you can't say that until y is alone, but then once it is, if it's less than, it's below all the time. Okay, what we're doing today, you can see the name on the screen. This section is 5-7 solving quadratic inequalities. Well, it's going to be very similar to what just happened, except our shape is going to be a parabola instead of a line. Other than that, not much is going to be different, which is going to be nice. Now, your homework, briefly. I don't know why I have this on here. Ignore that. I don't want to go over very much because we've done so much in this homework review already. I emailed today the link to all of the answers to the evens here. It is in your levhs.org email right now already. It's also where I put all the lecture notes everywhere for class. So if you want to go look at every little problem, you're welcome to. But we could do just maybe like a couple if you still need to, but we've done so many of these. Is there anything from the homework that you would like to do? Yes, ma'am?
36.
36. Okay. 36 is about the very smart, safe career of being a tightrope walker, which, you know, a lot of you are going to want to go to college and eventually grow up to become one of those. You know, tightrope walker, that is. Because if you're a tightrope walker, you get to, first of all, wear those pants, and second of all, perform in front of a bunch of dots. So something to look forward to. All right, so look, they give you an equation here, right? Look at this. The height, you plug in time, and you get the height. Here's the y-intercept. It starts at 60 minus 16t squared. What would this parabola look like? You'd graph it and it would look like this, right? No, it would look like this because the squared term is negative, so this would be an inverted parabola. It would be upside down, just so you're aware. Now, we're used to them saying things like, how many seconds will the tightrope walker fall before hitting the ground? Right? Because we've had problems where something is falling before, and it's always hit the ground. And when it hits the ground, h is 0. And so you'd substitute 0 equals 60 minus 16t squared. But that's not this problem. We don't want the tightrope walker to hit the ground. We don't want him to die. What is the tightrope walker going to hit in this little problem? Safety net, which is 11 feet off the ground. So you are going to set h equal to 11. So 11 equals 60 minus 16t squared. Now, if we're going to solve this, we must set it equal to 0. Let's move these guys over here. I'll have 16t squared. If I subtract 60, that's negative 49. Now let's be smart here. I mean, the goal is always to be smart, but in particular, I know this is the quadratic equation section. Is the quadratic equation the most efficient way to do this? Not even close. First of all, I mean, this factors, guys. This is a difference of two perfect squares, right? So, I mean, so you could factor this, or you could, even simpler than that, since there's a t squared but no t, you can get the t squared alone. Divide both sides by 16. You get t squared equals 49 over 16. Take the square root of both sides. You get t is equal to plus or minus 7 over 4. But I don't care about the minus because this is a word problem. And negative 7/4 seconds doesn't mean that. What's 7/4? 1 3/4 seconds, I think? Is that the right answer? Yes, it is. 1 3/4 seconds. So there you go. That's 36. And Danielle, you get the last question. What is it? Oh, you have to go. Okay. Bye. Have a nice time. Soccer game. Okay, put this away, please, and let's do new stuff. Here's your goal. Get it written down. There's a couple typos in here. I'm sorry about that. I didn't do a very good job when I typed that out. I left some things out. So copy that, and then we'll get going. Our goal is to learn to solve quadratic inequalities in 1 and 2 variables using 3 means: graphs, algebra, and your graphing calculator. The big difference between the two is if you have something that has 2 variables in it, you need to solve it on an x, y coordinate plane. You need 2 dimensions. You need a graph, basically. And if you have something with only 1 variable in it, only an x, you don't need all that. You just need a number line. So there's going to be basically 2 categories of what we're doing. Do we have 2 variables? If so, we're going to graph it like normal. Do we have 1 variable? If so, we're going to just stick with a number line and keep it simple like that. And here we go. Look at that table. It's all blocked out. Okay, let me clear some of this stuff here. 2 variables. How do you solve a quadratic inequality with 2 variables? Like y is greater than x squared, blah, 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 blah. Let's go through the steps here. Step number 1 is you graph the parabola that defines the boundary. How? Any of the ways that you've learned. Any of the ways. You can factor it and find the roots where it crosses and sketch it. You could use the quadratic formula. If you're allowed to use your calculator on that problem, you can just pick up your calculator and plug it in to see what it looks like. Any of the means of graphing that we have used, that's what you use. After you've graphed it, step 2, just like the warm-up, step 2, if you have a solid, you make a solid parabola if you have less than or equal to or greater than or equal to, and you make a dashed or dotted parabola, right, if it's just less than or just greater than, exactly like the warm-up, exactly the same, except we'll have a parabolic shape instead of a linear shape, but same difference. So, your graph may look something, instead of this, it might look something like this, possibly, for example. And then step number 3 is to shade. Just like the warm-up again. Shade above for greater than or equal to, and below for less than or equal to or less than. Exactly like the warm-up. So if this right here, if this guy was a y is less than, this looks like maybe x squared minus 2 or something. Less than, in this case, would be that, right? So for a parabola opening up, greater than above the parabola would sort of be inside it, and less than would be on the outside. So the parabola is like your boundary, your fence that separates your answers from your non-answers. And that's how it goes. Now, if you forget to shade, you haven't answered the question, right? You just left out an infinite number of answers. So without the shading, you got no answer. Let's do one. Let's graph this. Put this guy over here. Okay, step 1 is to graph it. You could pick up your graphing calculator right away. Or you can take a look at it just for a second and see if it factors. Does it factor? Yeah, I think that's faster. So give me a sketch of that. when you're doing this, you really end up working with what's called the related equation. Basically, that just means, let's pretend it's an equation for a second, and we'll worry about the absolute, the inequality in a little bit. That's the idea behind that. What are my factors, guys? It's exactly right. Okay, so your two zeros, your two roots, your crossing points are 5 and 2. So you go over here. Go, okay, 5 and 2. Solid or dotted parabola? Solid. Solid, because your inequality is greater than or equal to. And x squared is positive, so it opens up. So all that information means I do a simple sketch like that. Shade above. This is easy, right? Yes. The ones with two variables, guys, are easy. If you've got an x and a y, you graph it on a coordinate plane, easy, everybody's happy. Now, let's do one where the big difference is that, what? There's only one variable. These are actually a little bit more tricky. They're not simpler. It's the other way around. They're not too bad, though. So one variable means we're going to graph it on a number line. We don't need an xy coordinate plane. Just a number line will be fine. So here are the steps. Number one, write the related equation. So I'm going to start off by doing x squared minus 10x. I'm going to add the 3 to move it over here, so I'll have plus 21 equals 0. Treat it as an equation. Ignore the whole inequality business for a little bit. Step number 2, solve the equation and find the critical values or solutions. So factor it, quadratic formula, whatever you want. Let's see. Abby, does this factor? Anything multiply for 21 and add for minus 10? Sure. Absolutely. Right? Multiplies for plus 21 and adds for minus 10. And so we have two roots, two zeros of 7 and 3. Now, if my original problem was just an equation, these would be called the answers to the problem, and we'd be done. But we have an inequality. So these are going to be helpful in getting there, but I'm not all the way done yet. These are called, your book calls these the critical values. They're the things that you're going to use to help you get your answer. And here's how. Step number 3, test an x value in each interval. What the heck is that? Well, here's what we're talking about, okay? First of all, I need a number line. Let's get a number line that goes from, let's see. Let's get a number line that goes from 1 to 8. Okay, so here it is. Now, I'm going to take the two roots, the two critical values that I got, 7, and I'm going to put a filled-in circle on 7 and a filled-in circle on 3. Notice I'm putting a filled-in circle, not open circles. You know why that is, right? Because my original inequality was less than or equal to. So that's the filled-in circles. Now, look what's happened here, guys. My original inequality, which I'll write down here, okay, x squared minus 10x plus 18 is less than or equal to minus 3. I have gotten these two values, and they chopped my number line up into 3 distinct pieces. See that? There's there's the space in between them, there's the space over to this side, and there's a space over to this side. I have to figure out which of those regions my solutions are in. So we have to check. We have to test. Let's start out by testing. Let's test one in this region over here. What is the easiest possible value from all the x's that are less than 3 that you could plug in to check? 0, right? 0 is over here, so let's use it. X equals 0. So plug it right in here. I've got 0 squared minus 10 times 0 plus 18 is less than or equal to minus 3. Goes away. I've got 18 is less than or equal to minus 3, except no, it's not. And so this is not part of my solution. Moving to the next one. Let's check the region in the middle. I don't know. Let's plug in 5. 5 sounds good. X equals 5. Plugging it into my original inequality. 5 squared minus 10 times 5 plus 18 is less than or equal to minus 3. Let's see, this is 25. Take away 50 plus 18 is less than or equal to minus 3. That's negative 25 plus 18 is negative 7 is less than or equal to minus 3. That's good, right? Helps. Okay, so far, I have discovered that the middle region I can now go ahead and shade in. Because points in there are going to work just fine for that one. You have to check one more. You have to check the region out here. X is greater than or equal to 7. Pick like 8 or something. Check it, see if it works, please. Does it work? No. It doesn't. It doesn't. So you checked all 3 regions, and the only one that works is in between there. Now you have done enough of these graphs to know. Is this in-between kind of thing here, is this an and interval or an or interval? And. So how do we write this algebraically? Write it like this. X is less than or equal to 7 and greater than or equal to 3. There's my answer. All compact into one thing. This is called compound form. Can you write an or interval like this? No. You have to split ors into 2 pieces. You could say x is this, or, and then the other side x is this. So here's my answer. You may also see it written in this notation. Do you remember this? What is that? Interval notation. And there you go.